So today we're going to learn about the squeeze theorem, or some people call it the sandwich theorem, all right? And it's basically a way to find and determine limits for ones that we can't use algebra on, okay? So like we did some of them like sine of x over x, okay? The limit as x approaches 0. That could be determined using this squeeze theorem, okay? I'm going to keep this really simple. We're going to do this a lot of times graphically. This is what it says, okay? If for all x not equal to c in some open interval containing c, so c is in between some x values, okay? And for this to happen, g of x is less than or equal to f of x is less than or equal to h of x. So the g of x and the h of x are basically like the bread. Okay, so this is the outside, and here's our sandwich, and here's our meat inside, okay? So, all right, so we have to establish this, that there's a function between two other functions, and this is actually the one that we're trying to find, okay? And if we take the limit as x approaches the c value of g of x, and we do the same thing with h of x, the two outside functions, okay? And they equal the same number, the limit is the same, all right? Then what that means is the limit as x approaches c of f of x would have to exist, and it would also equal L because it's sandwiched in between. I'm going to show you a graph down here in just a minute and talk about it more, okay? So in other words, okay, if f is squeezed between two functions that have the same limit as x approaches c, then f has the same limit, okay? And the same theorem applies if x approaches, either infinity or negative infinity, okay? All right, so here we go. All right, so this function right here, let's not worry about what it is, okay? But we're going to call that one the outside function, okay? Or y equals h of x. All right, and then this is the function we're trying to find. So this one is going to be y equals f of x. And this one down here is y equals g of x. And you see how f of x is sandwiched in between these two. All right, so we're actually trying to find the limit as x approaches c of the black one, okay? So this would be, we can call this c right here. All right, and so I'm gonna just go on either side of that, and I'm gonna call this a and this b, all right? And you can see that both of these at c, these are both approaching the same value right here, right? So this is my limit, this is my L right here. Okay, so to do this, we have to show that g of x is less than or equal to f of x, which is less than or equal to h of x, and this open interval that we're talking about is a to b in this case, all right? And so we know from all this that the limit as x approaches c of g of x, and that's a one-sided, right? So the one-sided limits have to exist, and they do. They approach the same value. Okay, for g of x, they'd be up here, and then this would equal L, and the limit as x approaches c of h of x is also equal to L. All right, so f of x is in between these. Now this is the hard part that I'm not going to make you guys do. Trying to come up with these actual functions is really, really difficult, and really, really takes a lot of math knowledge to do. So we're going to kind of skip that part, okay? So we can say, therefore, the limit as x approaches c of f of x, the one we're actually trying to find, must also equal L. All right, let's do one that goes to infinity. So this top one, okay, this is the f of x. I should say that one probably first, okay? So this one right here is y is equal to f of x. This one is above this one always, okay? So that'd be y is equal to h of x. And then this bottom one right here is y is equal to g of x. Okay. So if you look, this is approaching this value right here, right? And it's approaching, this would be my L right here as x goes to infinity, okay? So this is gonna be my L value. Right here, somewhere, you know, in here is gonna be my A, okay? So what do we know? We know g of x is smaller than the f of x. So g of x is less than or equal to f of x, which is less than or equal to h of x. And for what? Now this is an open interval, so we could say for x greater than 0. Another way we could say that is we could say 0 to infinity. Okay, and we look at this. Okay, so this g of x function is approaching this limit L. So the limit as x approaches infinity, because we're going to the right here, of g of x is equal to L, and the limit as x approaches infinity of h of x is equal to L. So this is the bottom half of the bread. This is the top half of the bread. My meat is somewhere in between, and these are both approaching the same value. So therefore, the limit as x approaches infinity of f of x must also equal this number L, okay? So it's basically this. You got to establish that there's a top function that's always above the one we're trying to find, one that's below the one we're trying to find, and they're approaching the same limit value, okay? All right, let's do a problem now. So this is our function that we're trying to find the limit. The limit as x approaches 3 of f of x, all right? Above that function is this blue one, right? And it's actually the absolute value of x minus 3 plus 2. Below it is this one, negative absolute value of x minus 3 plus 2, okay? So we're going to let g of x, and this is what you'd have to do. You'd have to come up with this. You're not going to have to do that because I'm giving it to you, okay? Let g of x equal negative absolute value of x minus 3 plus 2, and we're going to let h of x equal the blue one, the one up here. Okay, so that'd be the absolute value of x minus 3 plus 2. Okay, so what do we know? We know that g of x is less than, by looking at the graph, we're just doing this by looking at the graph, okay? G of x is less than or equal to f of x, which is less than or equal to h of x. All right. And when is this true? This is true from, and you can do any open interval. They're approaching the same value right here at 3, right? Because that's the one we're trying to find the value of. So any open interval outside that, okay? So this is true on, and you could write 2 to 4. You could write 2.5 to 3.5. You could write 1 to 5. I'm going to write 1 to 5. Okay, so this has to be true on some open interval. So open interval means no endpoints, okay? What do we know about the limit of this one, right? It's approaching 2. So we know the limit as x approaches 3 of g of x. Okay, so we can read it off the graph. That would be 2. And the limit as x approaches 3 of h of x, the top one, right? That's also 2. Therefore, okay, or you could say so. Okay, I'm going to say therefore. Therefore, we don't even know what f of x is, but yet we can still find the limit of it, okay? Therefore, the limit as x approaches 3 of f of x must equal the same limit of 2, because f of x is in between g of x and h of x, and both those have the same limit on from between 1 and 5. Okay, let's do another problem. So this time we're going to use the graph and the squeeze theorem to determine the limit as x approaches negative infinity of f of x. So right here, this is f of x, the black one. okay? So you can see the top curve, right, which is y is equal to -1 over x minus 1 minus 3, is always slightly above it, right? And the limit, and this red one is always slightly below the function, okay? So we want to let, actually we'll just let h of x, and the names aren't really that important. I mean, if you call this one, this top one g of x and the bottom one h of x, as long as you put them in the right order, that'd be okay, all right? Let h of x equal -1 over x minus 1 minus 3, and we're going to let g of x, that's usually the bottom one, okay? That'd be 1 over x minus 1 minus 3. And so we know g of x is less than or equal to f of x, just by inspection, by looking at the graph, which is less than or equal to h of x, all right, on, and where can we do this? Well, anywhere from -infinity up to, like let's say -2 or 0, you could do any of those, okay? So let's just go -infinity to -2, okay? And so what do we know about the limit as x approaches -infinity, because that's the one we're trying to find, of this bottom function, g of x? Okay, so what are we looking at? We're looking at it approaching -3. So this is equal to -3. And the limit as x approaches -infinity of the top function, h of x, that's also equal to -3 if you look at this, okay? Now, f of x is sandwiched in between, and since these two are approaching -3 as x approaches -infinity, f of x has to do the same thing. So the limit as x approaches -infinity of f of x must equal -3. All right, and this is a way to determine. Now, what's hard is here's this function, right, f of x, and trying to come up with h of x and g of x. That's what's really, really, really difficult, okay? All right, a lot of even math teachers have a really tough time determining, okay, because you got to make sure that that function is always above it or always below it, okay? And to come up with those functions is difficult, okay? So this next one, okay, we want to find the limit as x approaches 0 of sine x over x. So that's this black one, right? Okay. And it just has to be in open intervals surrounding this that you have to have a top function and bottom function. Because if you look over here, all of a sudden it switches, right? So we wouldn't want to be out here when we describe our interval, okay? But we're going to let g of x equal cosine x. And we're going to let h of x equal 1, okay? And so what do we know about this? Okay, so this f of x, which is sine x over x, right? The bigger one is 1, and the smaller one is cosine x. So we could write g of x is less than or equal to f of x. And we're going to let, I should have said this, let f of x equal sine x over x. If you're going to use something like f of x in this, then you have to state it, okay? So you have to state f of x is equal to this, okay? So g of x is less than or equal to f of x, which is less than or equal to this h of x, okay? And this is true on an open interval, so you could do anything, okay, between, it would be true for any value between this value and this value, okay, the intersections. You can come even closer though. You could go -3 to 3, you could go -2 to 2, you could even go -1 to 1, it would be true, okay? So you just kind of establish that this is true for some open interval, okay? So this is true on -1 to 1. Again, you'd be fine if you wrote -2 to 2 or -3 to 3 or even -4 to 4, okay? So what do we know about the limit as x approaches 0 of this one that's underneath, g of x, right? Well, what is that approaching? Well, it's approaching the value of 1. What's the limit as x approaches 0 of h of x? Well, it's also equal to 1. In fact, it stays 1, right? Okay, so since this f of x is equal to sine x over x is sandwiched in between these, that's what this says, and the outside limit and the two outside limits are both equal to 1, the limit of the inside function must be the same because this f of x is sandwiched in between these, okay? So the limit as x approaches 0 of sine x over x is equal to 1. And that's one we did. We actually did the same one a while back. We didn't do it this way. We didn't use the squeeze theorem. What we did is we used a table to figure this out, okay? So for this next problem, I haven't given you a graph, but I have given you the function g of x, and I've given you h of x. And right here, I'm telling you f of x is sandwiched in between g of x and h of x. And here's my open interval from -2 to 2. This is true, okay? And this is an actual AP exam question that they asked a few years ago, okay? And I never used to teach the squeeze theorem or the sandwich theorem, and because there's other ways to do this that's actually easier later on, but the way they asked the question required us to use the sandwich theorem, okay? So that's why I started teaching this last year, all right? So it was actually 2019 is when they first had it, okay? It's the first time I'd ever seen the squeeze theorem on the AP exam. So here we go. We want to establish what's the limit as x approaches 0 of f of x, okay? So we already know this. We know it's given to us. G of x is less than or equal to f of x, which is less than or equal to h of x. For or on, okay? We say for when it's an inequality. For -2 less than x less than 2. We say on if we use interval notation. So -2 to 2. You could use it either way, okay? All right, now we want to find the limit as x approaches 0 of f of x. Well, we want to show that the limit as x approaches 0 of g of x. We got to figure that one out, and we got to figure this one out. And if they turn out to be the same, then f of x would have to have the same limit. That's the whole idea behind this, okay? So let's find the limit as x approaches 0 of g of x. Okay, so that's the limit as x approaches 0 of g of x, and g of x is negative absolute value of x. And what I've taught you is always try the first thing to try is direct substitution. Can we try to put 0 in? And the answer is yes. So what's the absolute value of 0? It's 0. What's negative 0? It's 0. So this is equal to 0. And let's also find the limit as x approaches 0 of h of x, the outside function. So that'd be the limit as x approaches 0 of the absolute value of x. Again, you can do a direct substitution, and that's equal to 0. And therefore, f of x is sandwiched in between. And as we approach 0 with x, the one below is approaching 0, and the one above is approaching 0. Therefore, the limit as x approaches 0 of f of x would also have to equal 0. So we found the limit using this sandwich theorem. Next problem. So here, g of x is equal to negative x squared plus 4. H of x is equal to x squared plus 4. G of x is less than or equal to f of x is less than or equal to h of x. So f of x is sandwiched in between these. And this inequality is true for x's between -4 and 4. Find the limit as x approaches 0. 0 is in here, okay? And then justify your answer, okay? So that means we need to show g of x is less than or equal to f of x, which is less than or equal to h of x, for -4 less than x less than 4. Or you could also say on -4 to 4. And so we need to find the limit as x approaches 0 of g of x. And that would be the limit as x approaches 0 of negative x squared plus 4. We can do a direct substitution. That would come out to be 4. And the limit as x approaches 0 of h of x. That's the limit as x approaches 0 of x squared plus 4, which is equal to 4. Those are the same. Therefore, the limit as x approaches 0 of f of x must also equal 4. Let's do a couple more. So for this one, g of x is equal to negative 1 over x. H of x is equal to 1 over x. G of x is less than or equal to f of x, which is also less than or equal to h of x, for x greater than 0, okay? And then the limit, we want to find the limit as x approaches infinity of f of x. And so what we need to establish is that g of x is less than or equal to f of x. And you got to say this, okay? You got to say what I'm writing here, even though it's said right here, okay? H of x on, okay, so I'm going to use interval notation, okay? And that would be 0 to infinity. So we've established that f of x is in between by it's given to us. And so we need to find the limit as x approaches infinity of g of x, which would be equal to the limit as x approaches infinity of negative 1 over x. Now, this means this denominator keeps getting bigger and bigger and bigger, right? So which makes the fraction get closer and closer to 0. So this turns out to be 0. Even though it's negative, it's approaching 0 from the negative side. We don't need that. It's just going to be 0. And the limit as x approaches infinity of h of x is equal to the limit as x approaches infinity of 1 over x. That's going to be positive, and we're going to go to 0 also. Okay, so we've shown that the two outside functions are both approaching the same limit value. So therefore, the limit as x approaches infinity of f of x must equal 0. I almost wrote 0 here. That should be infinity right there. Okay, actually, I can't handle it. All right, I gotta fix it. Infinity. That still looks bad, huh? All right, infinity there. All right. All right, last problem. G of x is negative e to the x plus 3. H of x is equal to e to the x plus 3. And g of x is less than or equal to f of x is less than or equal to h of x for x less than 0. So this is actually how they asked the question a couple years ago, okay? And we want to find this limit as x approaches negative infinity of f of x, all right? All right, so we know from this that g of x is less than or equal to f of x, which is less than or equal to h of x on, and we're saying x is less than 0, right? So that'd be negative infinity to 0. And now we have to do the limits. So the limit as x approaches negative infinity of g of x equals the limit as x approaches negative infinity of negative e to the x plus 3. Okay, so here's a perfect example of it'd be nice when you see these exponentials, put in a big negative value in here. So do not put equals here and then put the number in, because that's wrong. I will count it as 0 because it's totally incorrect. All right, because this is x is getting closer to this, and then if you say this is equal to, that's a 1 value of x, not x is approaching. Okay, so let's do like negative 1,000. So this would be something like this: negative e to the negative 1,000, and this is just to help us see what's going on. Okay, so what does e to the negative 1,000 mean? It really means this would be negative 1 over e to the 1,000 plus 3. Well, 1 over e to the 1,000 power, that's going to be really, really big. This is really, really close to 0, and we're adding 3 to it. So this is going to equal 3. And that's the answer to this. It's 3. Okay, so we need to do the h of x also, right? So the limit as x approaches negative infinity of h of x, the outside function, right? The one that's always larger, that's equal to the limit as x approaches negative infinity of e to the x plus 3. Okay, again, don't put equals, all right? Let's try a big negative value in here. So that'd be something like this, e to the negative 1,000 plus 3. This becomes 1 over e to the 1,000 plus 3. That's a really big denominator. So this is getting closer and closer to 0, and adding 3 to a number that's getting closer and closer to 0 is just going to give you 3. So this one's equal to 3. So the two outside function as x approaches negative infinity are both approaching 3. The sandwiched function that's in between, the meat of the sandwich, all right, must also approach, because it's in between, it must approach the same value. So therefore the limit as x approaches negative infinity of f of x must also equal 3. All right. And like I said earlier, what's really, really hard is coming up. Like if I just gave you f of x as this function, right? You actually know what the f of x function is. It's really, really hard to find these two outside functions, the one that's above it and one that's below it. Very, very difficult, okay? And we'd also want to have them approach the same value as x approaches negative infinity. Very difficult for all those things to happen, to come up with a function that is all of that, okay? All right, that's it, guys, for today. All right.